Okay, today we're going to review solving linear equations. To solve a linear equation, the strategy we use is the principle of equality. Basically, what the principle of equality tells us, if two things are equal, if you do one thing to the one side and one side to the other side, as long as it's the same thing you do to both sides, you stay equal. If you think of like a seesaw effect, if one child is 50 pounds, the other one is 50 pounds, it's equal. If one of them invites their kid brother who's 30 pounds and the other one his kid sister, which also happens to be 30 pounds, one gets on, the other one gets on, it's still balanced. So if you start with equality, add, subtract, multiply, or divide the same sides, each side by the same number, you're still equal. That simple process will allow us to solve any linear equation. For our first example, we'll try this one. 5t equals 2t plus 6. So we're trying to find what value for t will balance this equation. So first thing we notice is the t's on both sides. So we'll use our principle of equality to go ahead and take away 2t from both sides. And I'll just put it right under. That's the balance. If we take 2t from each side, on this side we've gotten rid of the t's, and now we just have a 6. And on the other side, 5t, take away 2t is going to be the 3t. At this point, we might just be able to look at it. 3 times what is equal to 6. But to just go ahead in our step, we'll go ahead and divide both sides by 3. At this point, we come up with our answer, which is t is equal to 2. And for this linear equation, this is the only solution that will balance both sides. If we can go ahead and try to check real quick just to verify it works. 5, if we put in a 2 in, it's going to be 5 times 2, which is 10 on the left-hand side. On the right-hand side, if we put a 2 in here, 2 times 2 plus 6. 4 plus 6 is also 10. It balances. The only solution that will balance this linear equation is 2. We've used the principle of equality twice. First subtracting 2t and then dividing by 3. Okay, for our second example, we'll try the linear equation negative 2t minus 7 is equal to 5. Again, we're going to try to isolate the t. In this case, we'll add 7 to each side to eliminate the 7 here. In this case, I'm going to go ahead and write the actual principle of equality right on the line. So in this case, we're going to add the 7 to both sides. Okay. This will help us get rid of the numbers in this case. We're just going to have the negative 2t is going to equal to 12. At this point, you might be able to look at it and see what the answer is, which is good. But we'll just go ahead and apply the principle of equality one more time, this time dividing both sides by negative 2. And we're left with our solution, which is t is equal to negative 6. We'll go ahead and check it briefly. Put a negative 6 back in as the value of t. Negative 2 times negative 6 minus 7. 2 negatives become a positive. 12 minus 7 is 5. And the other side is also 5, so it does balance. This time we applied principle of equality twice. We first added 7 and then divided by negative 2 to isolate our variable t. Okay, for our next linear equation, we'll try this one. 3 times the quantity x plus 5 is equal to 4x plus 12. In this case, before we start our balancing game and using the principle of equality, we need to distribute this as 3. So we're going to go ahead and distribute it through. I'll just draw little arrows to indicate to distribute. And 3 times the quantity x plus 5 is going to be 3x plus 15 is equal to 4x plus 12. All right, at this point we notice we have 3x and 4x. So in this case, I'm going to go ahead and put all the x's to one side, and I'll go ahead and take away 3 x's from both sides. So think of it as subtracting 3 x's. Okay, in this case, as the x's go away like we wanted to, and we're left with 15 is going to equal to x plus 12. Again, at this point, you might just be able to read the solution out. Good. Let's just go ahead and actually show the step. In this case, we'll subtract 12 from each side, and we've gotten our goal of isolating the x. And our final answer for this one is going to be x is equal to 3. Let's just see if we can visually check this one. If we plug a 3 back into the original, 4 times 3 is 12. 12 and 12 is 24. On this side, 3 plus 5 is 8. 8 times 3 is also 24. It does check. Okay, on this example of a linear equation, it's a little different. We have a fraction as a coefficient. There's actually 2 ways to approach this one. Let me go ahead and talk through one way, then I'll actually do a shortcut version on the board for you. One thing you notice is the 2/5. We can treat this as two different properties, multiplying by 2, dividing by 5. So if you want to do it on 2 steps, you can multiply both sides by 5 to get rid of the 5, then divide by 2. Okay. To go ahead and look at it in one-step process, I can rewrite this 2/5 x equals 4. And notice, if I want to get rid of this 2/5, the inverse operation of multiplying by 2/5 is multiplying by its reciprocal, which is 5/2. If I put that on both sides, what it accomplishes for us is that it cancels out nicely. The definition of a reciprocal is the number that you multiply by to get to 1. It cancels out nicely. We just have the x left. And on this side, we multiply through. 5 times 4 is 20. Half of 20 is 10. Okay. Again, so if you have a fraction coefficient, you could actually multiply through by the denominator to get rid of the fraction. Or you could just go ahead and in one fell swoop multiply by the reciprocal to go ahead and get rid of the entire fraction. At this point, we can do a just quick visual check. 10 times 2 is 20, divided by 5 is 4. Okay, this is the last linear equation we'll review today. In this case, we have 2x plus 19 is equal to 4x plus 7. The unknown appears twice. Notice on each side, we can't really simplify. We can't combine the 2x and 19 nor the 4x and 7. They're not like terms. So in this case, what we want to do is use the principle of equality. And this problem is going to require the maximum usage of the principle of equality, which is 3 times. So the most we'll have to use in any one linear equation is 3 times. And this one will be really as tough as it'll get. So in this case, we'll go ahead and subtract the 2x from each side to try to isolate the x on one side. In this case, the accomplishes gets rid of the x's here for us. So we're left with 19 is equal to 2x plus 7. Now we have the x on one side. We want to go ahead and get the numbers to the other side. So we'll go ahead and take 7 away from each side. Okay, the 7's are gone, the 2x is isolated, and we're left with 2x is equal to 12. Okay, again, you might be able to read off the solution. It should be 2 times 1 is 12. We'll just go ahead and show it through by dividing both sides by the coefficient 2. And we're left with our answer, x is equal to 6. All right, notice this was the maximum times that we'd have to use the principle of equality. We used it once to subtract the 2x from both sides. Then we used it to subtract the 7 from both sides. And finally to divide by 2. Last, we'll just quickly check that 6 actually does balance this equation. 2 times 6 is 12. 12 and 19 is 31. On this side, 4 times 6 is 24. 24 and 7 is also 31. Okay, this has been a review of linear equations for you. If you need more information, you can look at the link that appears below the page with handout with more information, and hope to see you in math class at Solano College.